What's up, Algebra 2? Here we are with 6.6, rational exponents. Rational means you can write it as a fraction. So we're having fractional exponents today. Alright, so we're going to be having things of the nature w to the power of x over y. W is your big base number. X, the top part, the numerator, that's your power. And y, the bottom part, is going to be considered your root. So if we were talking x to the 1/6, that's x to the first power, and we're going to do the sixth root of that. So if we're going to change it from exponent to radical form, we've got the sixth root of x to the first. Okay, you try this one and think about what this one would look like. Alright, were you getting x to the third and then the fifth root of it? So we got the fifth root of x to the third. Okay, let's go the other way. What if I had the fourth root of x? How could I write that in a rational exponent form? Well, it's the fourth root, and I don't see a power there, so it's x to the first. So we're going to have x to the 1/4. Okay, you think about this one. All right, we have x to the third, and we're doing the fifth root of it. So x to the 3/5. Power on top, root on the bottom. Okay, when we're evaluating these things, when it's just like a number to one of these powers, we can think about it a couple different ways. All right, number one, you could type it into the calculator. Boo, boring. Okay, if you want to try to do it mentally, I would suggest doing the root first. Make it smaller first for a couple of reasons. Number one, if you made this number bigger first, you're probably not going to know the root of it. You're going to have a less likely chance of knowing how to do the root. Okay? If you did, and then also by making it smaller first, you're going to have a much easier time doing the power. Okay? I'm not going to know how to do basically either one of these in my head. 2/16 squared, not going to know how to do that. Or the cube root of whatever that massive number is, I'm not going to know that either. Alright, but the cube root of 2/16, that's not too far. Let's see, I think most of our cubes we went to 3, 4, 5 cubed is 125. Okay, 6 cubed is going to be 2/16. So the cube root of 2/16 is 6, and then we square it, 36. So we did the cube root first. It was 6 squared 36. Okay, 216 squared, if you did the power part first, man, you're going to have to type that into the calculator. 46,656. And then to know the cube root of that, whew, no chance, all right? You have to type that in again, 36. Okay? You could type it in at the end to check yourself if you aren't confident in your answer. Okay? We could do 2/16, exponent key, to the 2 divided by 3 power. Okay, we could do, if you want to do the root, we're going to go math. The cube root actually has its own thing. We could do that. Okay, just going to show you this one, the x root, just because then you can do anything. Okay, x root, and I could type in whatever root number I wanted there in that spot, but we want the cube, so I'm going to go 3. 2/16 is 6, and then 6 squared, 36. All right. Let's see what we got on the back side. 81 to the negative 1/4 power. Okay, so that 1/4 power means the fourth root. So let's do our root first. What is the fourth root of 81? And then let's do that to the negative 1 power. What times itself 4 times gets me to 81? Well, 3 times 3 is 9, times 3 is 27, times 3 the fourth time is 81. So the fourth root of 81 is 3. And then 3 to the negative 1 power is going to be not negative 3, but 1 over 3. It flips it upside down. (256 to the 3/8). Okay, 256 to the 3/8. Again, Mr. Handke likes to do the roots first. Okay, wild guess here. It's actually probably not a wild guess. It's probably a pretty educated guess. What do you think the 8th root of 256 is? Something times itself 8 times in a row. Boom, 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 boom. It's going to only be 256. Yep, we're going with 2. It's 2. And then 2 cubed is 8. All right, simplifying with powers. X to the 3/7 times x to the 2/7. When we're multiplying, we get to add exponents. So this is going to be 3/7 plus 2/7 for x to the 5/7. Okay. If we were dividing, let's change that to a dividing one. Let's see, where can we go with space? X to the 5/7 over x to the 2/7. If it was dividing, then we would subtract 5/7 minus 2/7. And these have both had common denominators, so we didn't have to do anything with that. There we get 3/7. But if they didn't have common denominators, you'd have to do some junior high fraction math there and get some common denominators so you can add and subtract fractions. Z to the negative 5/6. Okay, we had one of these with an actual number, but what about with a variable that we can't actually do, like the 6th root? Okay, so the negative exponent is just going to flip it upside down. We're going to have 1 over z to the 5/6. Okay? And just like with roots, we can't have a partial power on the bottom. So I need one more sixth. Z to the 1/6 on top, z to the 1/6 on the bottom. Okay, and z to the 6/6 is just going to be z to the 1st. All right? Let's see. There's another one I want to teach you about here, too. Let's do this. Let's do 2x cubed parentheses squared. All right, just reviewing some power properties, some exponent properties from Algebra 1. Okay, if I have 2 to the 1st, this is really 2 to the 1st. And if you have exponents, parentheses to another exponent, we get to multiply. When you were multiplying two things, we added the exponents. When you have power, if you have exponents raised to another exponent, then we multiply the exponents. So this is going to be 2 squared and x to the 6th, which would be 4x to the 6th. Little bonus problem in there. All right. And our bottom row here. Okay, we got 27, the 4th root of 27, and the square root of 3. All right, there is no perfect 4 that's going to work with 27, because 27 is a cube. 3 times 3 times 3, that's going to give me 27. So we don't have a 4th one. But let's just write this as best we can here. This is going to be the 4th root of 3 cubed. And this is the square root of 3 to the 1st. Okay, so we have it in root form, and now we're going to change it to fraction exponents, rational exponents here. So we're going to have 3 to the 3/4 power over root over 3 to the 1/2 Okay, and we're dividing, so we get to subtract exponents. 3/4 minus 1/2. Okay, not a common denominator, but also not a terrible one to find. Right, 3/4 minus 1/2. We're going to change the half, 1/2, to a 2/4, so it matches up there. Okay, 2/4 is the same as 1/2, just we have a common denominator. And 3/4 minus 2/4 is going to be 3 to the 1/4 power. Okay, so we could go with that. Also, if they gave it the problem to you in root form, probably not a bad idea to turn this all the way back into root form for your final answer. So we have 3 to the 1st and then the 4th root. One-fourth. Okay. One more over here. This one should work out pretty clean. Pretty nice problem right here. Go ahead and push pause and try this one on your own. Alright, so 64 is actually 4 to the 3rd. And then we have z to the 6th. And if we're doing cube roots, those both work out pretty nice. 3 divided by 3, we got 4 to the 1st. Z to the 6th. 6/3 is going to be z squared. So this is 4z squared. Alright, crew. Thanks for watching. Best of luck. Let me know if you have any questions.